Hello, and welcome to the new Calculus channel. My name is Brandon R. In today's video, I'll be discussing the topic of arithmetic and the abstract unit. So let's begin. In order to perform arithmetic with ratios of magnitudes in geometry, we require that ratios have the same consequent. The four basic operations of arithmetic, difference, sum, quotient, product, are established using Book 5, Proposition 12, which is about similar triangles and proportion. For all the details on how we got arithmetic and its operations, click this link below. At this stage, everything we talk about requires geometry. That is, drawing the line representations, ratios, etc. In order to move to a diagramless theory, the concept of the abstract unit was introduced. Note that until now, there has been no mention or use of number whatsoever. The true story of how I got numbers is fascinating, and if you want to know about that, click the link below. Now I'll be discussing the abstract unit. Euclid's definition of the unit in Book 7, Definition 1, assumes a sufficiently knowledgeable person who has studied the previous 6 books. A unit is that by virtue of which each object is called one. A much simpler definition is, a unit is a ratio where the output parts are equal and represent the standard a measure. For a never-before-seen glimpse into the minds of ancient Greece, click the link below. Obviously, the Greeks were not satisfied having to use physical comparisons. They desired to refer to magnitudes without comparing to other magnitudes, and worrying about whether the ratios have the same consequent, etc. In the following article, John Gabriel gives you a glimpse of how a genius realizes the concept of number. This is very different to anything you've ever seen. Check out the link below. To accomplish their goal, the Greeks carried over all the geometric properties of arithmetic to the abstract unit, whose size and type is irrelevant. If they had continued to use only geometry, they would have used what is called a standard unit ratio. That is, a chosen magnitude which in any ratio is simply the comparison to itself. Hereafter, they would use this approach for proportion with other ratios. The role of proportion is central to the theory of arithmetic and the realization of arithmetic operations, and also the theory of fractions. And if you want to learn more, check out the article below. The process in algebra is identical, except that the unit can be any size since algebraic arithmetic does not concern itself with physical units as one finds in geometry. Physical units can be attached to measure but are not necessary. For example, area can be described as square units, volume as cubic units, and density as mass per cubic unit, where the unit can assume any physical size desired. Is the real number line real? If you want to learn more about that, check out the article below. A natural number is a fraction whose antecedent is a multiple of the abstract unit and whose consequent is the abstract unit. If p over q is a fraction, then we use q equal parts of the unit enumerated by p parts to represent any number. The drawback to this approach is that it sacrifices precision for generality because not all ratios can be described by their measures. A summary of the most important events in the perfect derivation of number, check out the article below. For example, the following ratio has measure. You compare from 3/4, the measure here, with the comparison of these dashed lines here. Whereas The ratio, when you compare the circle circumference to the diameter, does not have a measure. The constant pi is approximately equal to the failed measure of the ratio circle circumference to in comparison to the diameter. In order for any ratio to be measured, it must possess the attribute of quotients, such as from Book 5, Definition 3, meaning that both aliquot parts must have a common measure or divisor. And if you want to learn more about that, check out the link below as far as what quotient means. In the next video, I will be discussing or introducing the topic of algebra. My name is Brendan R., and this is New Calculus Channel. Thank you for watching. Goodbye.